Hello all. Good afternoon to everybody. Today we will discuss on high availability on Azure applications. Basically, the agenda of the seminar is that we will discuss uh, what is high availability and what is the background, why we need the high availability in Azure. When we are going to deploy any applications, running an application in the Azure, so why we need the high availability, what is that high availability, and how we can achieve that. And today in this seminar specifically we will discuss on the PaaS, mean platform as a service. Basically, not as you know, actually that in cloud actually you have the different options, right? Infrastructure as a service, platform as a service, and the service as a service. So today objective of the seminar to cover actually how the PaaS works in Azure. Basically platform as a service, that means web roles and worker roles works in Azure, how we and why we need the high availability in Azure for the web roles and worker role. What is the need of that? Why we should think of that when we are going to deploy any application in the Azure. Okay. So in the introductions first, when you are developing any applications and deploying to any cloud service or the any server, the first things we always think that actually how our application will be always available, right? So that actually there will be no downtime. Whenever we always think that actually, and our customer needs that also. Customer need that actually that applications should be available in 24/7, right? And another important thing that reliability and scalability also. How reliable is your applications, and when most important thing that availability always depends on the availability, scalability also. If our applications does not provide a good amount of load, does not support the good amount of load, and that time when we have the so many users hitting to our service or hitting to our applications and our applications fails to serve that request, then obviously that is also our application is not available. That means, right, from the end user perspective, our application will be unavailable. And that is the reason when we develop any applications from the coding perspective or that deploy the any applications, scalability also is very important. How we can scale our application so that at dynamic level, at the runtime level, it can basically handles multiple loads. That means handles the loads dynamically. Because we do not know, right, when we are developing the application, we do not know actually how many users will use this my applications. It can vary day to day wise, hour to day hour wise also might be, right? In the peak hour might be millions of people will hit our application, might be in downtime there will be no user for our applications. So that things we need to also think when we are deploying the application to the Azure. And third point is the design for failure, and it is obvious, right? Because when we are deploying any applications internally, it is a server, it is hardware, it's right involved, database is involved, storage is involved, network infrastructure is involved, server infrastructure is involved, and when you are going for the cloud, that visualizations, that different basically the hardware configurations is also involved. So there is so much chance that might be any of these, right, can fail at that time, at any moment, right? There is no guarantee that actually my hardware will be always actually available. There can be hardware failure, there can be network failure, there can be my basically the total server can be totally crashed, right? And due to basically suppose some natural disaster happen, then obviously might be total data center will be totally, right, will be lost. That means we can lose whole database, whole data center that time. So that is the reason actually we should design our application in such a way that even it should be fault tolerant, right? Any failure tolerant. Okay. And those last 2 points actually I will discuss in my next seminar, but these are the basically the strategy most of the people implement when you think of the high availability. Basically they implement separation concerns. That means instead of writing the very tight couple, we can actually go for that separation, we can separate our function in different layers, and we can deploy that layers in different parts. So it might be what we can happen might be if with that we can achieve the high availability, because if one will fail, then obviously other is available to serve our request, because we have separated our functions, right? And another thing that use as a service oriented architecture. Basically this is actually for the long time, and it is available for the long time, and most of the so many people say use the service oriented architecture to make it high level also. We can create different service, and our main application will call that service itself, right? Okay, so this is the agenda, and today I will cover some depth part of the infrastructure of the Azure, how really when we are talking about the web roles, worker roles, when we deploy as a developer point of view, we deploy our code to the worker role, web role, or the cloud service. That means PaaS means cloud service, right? Cloud service contains the units so that it can contain web roles and worker roles, right? It can contains multiple web roles and worker roles. So when you deploy any code to cloud service, what is happening internally actually? Who is handling all the things? Who is creating actually? Basically, what is happening when we are deploying the code internally? It is creating a server for us, right? It was not present before, right? Yeah. In Azure, actually, the visualization it will assign a physical server to us. Once it is assigned, then our code will be deployed to inside that machine, right? So who is handling that, right? That is the reason we will cover that architecture, Windows Azure role architecture, how it happens. Then we will discuss fault domains in the Windows Azure, then the update domains in the Windows Azure. Then the two most important concepts in Azure we need to understand to make why high availability is needed. Windows Azure host operating system updates, Windows Azure guest operating system update. When we are going for any visualizations technology, basically we have the one is OS operating system, another is guest operating system, right? That means OS operating system is set in the root partitions of the visualizations, and the once that is assigned, we have the multiple child partitions, that is called guest operating system. So we need to understand how this actually that updates happens inside the Windows Azure, so that then we can understand actually then techniques. I will discuss actually some techniques actually how we can avoid all the points which we discussed actually, how we can make our application to high available using some techniques. Okay. So basically, this first point is the, if you check this diagram, the first one is the RDFE/FFE, right? Fabric front end. That is the actually we can tell actually that end user will interact with the Windows Azure using this Fabric endpoint. Fabric endpoint basically gets the all API call from the Windows, basically the end user, and it will interact with the our Windows Azure management portal or the Visual Studio and create all the things for us. But that means that is the, we can tell the gateway to our Windows Azure. Okay.
As a developer or as a user?
Basically, it is happening internally. Nothing actually we need to take care of that. All the things I see, platform as a service means, right? You don't need to take care of anything. Windows Azure actually inside it is the internal architecture that Windows Azure will take care of everything. Whatever the things I am discussing now, it is handled internally. Nothing you need to bother. When I am calling, suppose I am calling some Windows Service API, sorry, Azure API, right? Like some storage. I suppose I need to create a container or some. Then who will receive that calls? Basically, this is the gateway to basically, right? Fabric endpoint will receive my API call and interact with the Azure and create all the things. And every call, everything. When we are deploying the code also, obviously internally that means what I am clicking the deploy code, that means I am sending some commands to the Windows Azure, right? That is the API call internally. Even using our some command, using the PowerShell command also I can deploy. And using the Visual Studio, that is a very simple to do because it is a GUI tool, simply. or I can write my simple code also to deploy. How we can do? We can write our own API. I need to call API, Azure API, then I can deploy, right? So who will receive? Who is handling the things? When I am going to deploy anything, or I am doing any operations related to the Azure, who is handling that? So gateway is the red frog front end or the slash fabric front end. Okay, the fabric word is very important because we will cover everything related to the fabric. Okay, so it after that what will happen? It receives the call from the end user and sends to fabric controller, and that is the engine of the Azure. We can tell the brain or engine, whatever term we can tell. Everything, whatever things inside happening in the Azure, from the end user's perspective or the from the Azure management point of view, everything is handled by fabric controller, right? So when we deploy our code, we are giving the code to Azure, right? And we are giving the service definitions, service configurations, and you are telling that how many roles we need to deploy, everything, whether we need to, what is the storage account we need to use, right? We can tell actually which database you need to use, whether SSL we need to use or not. Every configurations we can send, right? Fabric controller will get all the configurations, informations, service definitions, service configurations, code, everything. Then this will create a web roles, worker roles for us. Okay, that means that is the main important agent, or we can tell that the main brain of the Azure. Everything is handled by the fabric controller. So what will happen? It will get the information from the fabric front end FFE. Then it will pass all the information. This see, when we are talking about the visualizations, first the guest operating system, right? Then the first is the host operating system, then the guest operating system. So first task is to what? He needs to first get a physical server for us, where we need to deploy the code in the physical server. Without that, nothing is possible. After that, visualization comes, because we are just partitioning the physical server based on our requirement. It's assign the different CPU, the memory, hard disks, all the things, right, based on our requirements. And we are telling that also which open systems you need to need. Using the service definition, service concerns, we are passing all the information, right? Basically, which open systems, what is the family, OS family we need, what is the size of the system, how many roles you need to deploy. So it gets all the information, sends to which? Host agent, and host agents lives on host operating system. So after that, once host agents gets all the informations, it will pass all the informations of the service configuration, service definitions to what? Windows Azure Guest Agent. And Azure Guest Agent is managed by the WAF agent, Windows Azure App Agent. Are you getting point? Everything is basically this is managed by Windows Azure Guest Management is managed by the WAF agent. Okay. So once Windows Azure Guest Agents get all the informations, right? This will pass. It will create the WA host bootstrapper. That is the basically we can tell the entry point for creation of the web role and worker role. We can tell that will handle everything. Basically, we are writing our start of tasks, right? Whether we should create a web role or worker role, whether we need full IS or not, what are the configurations we need in the IS level also, right? All the things it will get from the Windows Azure Guest Agent, then it will handle everything. And fabric controller internally actually doing everything, right? Fabric controller sends all the information to host agent, right? And that fabric controller also every 15 minutes or 50 seconds, it sends a ping to each web role and worker role to check the health status. If at any moment it finds that if any worker role or the overall is down, then it will create another virtual machine for us. Getting? So it will send again the same request to the host agent. So in host agent, the same process will happen. Okay. I will share one links, and I have extracted this actually image from that link itself, and it describes all the things details. Okay. and it is out of scope to discuss all the points, basically the internal points. Besides, all those points are related to web roles, worker roles, how internally everything happens. Basically, the start of tasks, all the things, it is related to our programming. So, if you understand these things, it is a very good one. If you understand the internal architecture, that what will happen, that we can really, when we develop our Azure applications, we can write our code very efficient way. How we can handle our start of tasks, how we can handle our on start event, how we should handle our basically the on stop event, right? So that all the things you need to know to make sure that our Azure applications is high available. But I will discuss this part in my next seminar. In this seminar, I will try to cover actually all the things to high availability. Availability means actually really related to fast, actually that whenever we have any down of the data centers infrastructure down. Okay. So I will cover only that part only today. If any web roles or worker roles down, then how we can handle that part. If hardware failure, if any server failure, right, network failure, then how we can handle that one. So that means objective of this part is that we need to understand that our fabric control is the brain of the Azure. This is the one point you need to understand. Okay. When we deploy any code, fabric control gets our code configuration settings, and it will send all the information. It will assign a physical server to us. Also, it will create VM, right, virtual machine. That means web roles and worker roles for us. Okay. These are the 3 points you need to take. Then another concept in Azure, that fault domains in Windows Azure. What are the fault domains? Basically, these are concepts you need to understand to know actually how to know the techniques to make our Windows applications high available. Okay, that is I am discussing this. What is fault domain? Fault domain is a physical unit of failure. We can tell actually that basically it is a combination of different machines, you can tell. And what will happen that actually in Windows Azure, they are telling that rack can be considered as a fault domain. Suppose in data centers, we have so many, right, can be racks, right. So each rack we can tell actually the fault domain in practical sense. So what is the fault domain? That means internally, what will happen that whenever they are considering that they are combining that rack or that we can tell that physical servers to one physical group, one physical unit, so that whenever there will be any hardware failure or service crash, all the things that will happen only on that particular rack. It will not affect the other one. In that way, they have created different fault domains. Okay, are you getting my point? So yes, exactly. It is just physical unit of failure. So that what will happen that if I will tell actually all the details. So whenever we are deploying our applications with 2 role instances, fabric control will automatically basically deploy each role to one fault domain in different fault domains. So what will happen that if by any hardware failure or any regions one fault domain is down, that means one web role is down, then obviously other will be available, right? So there is no chance that 2 web roles will be down at a time, because both the web roles are present in different fault domains. Each web role will be present in the one fault domain. Are you getting my point?
For this case, the 2 different web roles, the processing is same, like the job of web roles.
Exactly. That means I have taken the 2 instances of the web roles. Okay, 2 instances of web roles. Okay. And last point is that we cannot control actually how many fault domains we can use in our applications. Fabric control will handle this all the things for us. Getting your point? Suppose we are telling that actually that we need to create the 10 instances of web role, then we will put probably 3 instances fault domain 1, another 2 instances in fault domain 2, another 4 instances in another fault domain. Getting your point? Fabric control will handle all the things for us. Okay. Update domain. This is the same. Basically, this is the physical unit, and this is the logical unit. What will happen that actually it also segregates the different servers, okay, and creates the update domain. And fabric control will handle that things also for us. But one point here is that we can by default it is basically the 5 of the domains will be assigned to one applications, one web roles. Okay, one cloud service. Yeah, yeah. So when we deploy our applications with minimum of 2 instances, then what will happen that Fabric Control will automatically deploy the each instances to different of the domains. Like fault domains, it will deploy the each instance to different of domains. Okay, and we can here one benefit is that with the object domains, that one difference is that we can control actually how many object domains we need in your applications. I can tell actually suppose 20 object domains I need, then I can configure that using the service definitions. Okay, but fault domains Fabric Control will automatically handles for you. There is no way that we can control that actually I need actually 20 fault domains or something. Okay.
Actually created within one data center. Suppose two instances it will create. Two instances for the particular data center, or the two instances.
All the things we are discussing inside one data center only.
Okay, so suppose that data center totally.
That is called actually yes. That is that is our next seminar basically. High availability I am discussing all the points which we can handle the basically our hardware failures or all the things. Okay. That is all different. What that is the reason Azure provides such a different option also, geo replication type of things. Getting point? When you are deploying an application in one location also, at the same time we can deploy in another location also. By any time due to natural disaster or something, total data center is not available. Then what we call obviously there is that traffic manager available. It will redirect all the request to next basically your secondary data center. And when we are deploying our storage or database, there is option also geo redundant replications. So that when anything we are committing to the database or the storage, another copy of the same basically same copy of the database or same copy of the storage will be created in another geo locations, another data center. Okay, there are different options are available. We will discuss in the next seminar. Okay, basically today we will concentrate on the total main infrastructure. If at all actually infrastructure will be done, how we can handle in the same data center itself. Okay. So we discussed basically that we have the in visualizations two things involved, right? One is guest operating system, another is OS operating system. And what happened that in Azure, basically they update the host operating system approximately once a month or once a quarter. Getting it? So why they need that? They are telling that actually they need, because obviously you know, right? They are doing so many updates, right? But the operating systems to make the reliable, efficient, and secure the platform. They are suppose they are releasing some patch to make operating system more secure, or they are missing some functionality. That time actually we need that, right? To make our application that means to make your hosting application more reliable, right, secure and efficient. Okay. So that is it is needed, and when it happens, basically I talked with Azure guys also how frequent this happens, that they are told that actually once a month or once a quarter, there is no guarantee. Okay, and there is no way that we can know actually when it will happen also. Getting my point? But when they will update actually, like they will do a major update, sometimes they will send mails to us. But for the host operating system update or guest operating, they don't send in notifications, and there is no way that we can know actually that there is event type of things that our application know that actually there will be a host operating system update. There is no way. So we need to create our applications and we need to build our infrastructure in such that it should be efficient to handle the host operating system update. So what will happen when it will update? So basically this the picture will give some information basically that host operating system, then the guest operating system. The upper part is the role instances we have, right, and lower is the host operating system, right. So this is the visualization concept. Okay. The first point is very important. The host operating system reboots instances and the fabric control ensures that only instances from object domain from one object domain at a time will be rebooted. So, we discussed actually what is the object domain, right. So, that means fabric controller will ensure that only instances from one object domain will be rebooted at a time. Are you getting my point? Suppose we have 5 instances, okay, 3 instances in one object domain, another 2 instances in another object domain. So, when OS operating system update will happen, what will happen that first it will update all the servers, that means all the instances present in object domain 1. Once those object domains will be rebooted and it is off, it is available to the end user, then all the instances available in the present in the second object domain will be rebooted. Okay. So, what happens basically when OS operating system updates? So, virtual machines running on the servers that have an endpoint in their role service model removed from the load balancer rotations, that so that no new requests come to the virtual machines. What will happen that basically if you basically here the host agent, we have got so many guest agents, and guest agents basically we have the load balancers after that, right. Suppose one web role has 5 instances, in middle we have the load balancer, right, and here also we have the load balancers present in the host operating system and the guest operating system. So, we can know actually which request will be gone to the which web roles inside the basically the in middle of guest operating system and the host operating system, and they are also in IS level. If you tell, then they are also load balancer is available. So, when OS operating system update starts, then what will then it will basically stops all the basically endpoints, roles endpoints will remove from the load balancer, so that they will not get any request from the end user. Are you getting point? We have the when we are deploying any applications in Azure, we have suppose we have 5 instances of a web role, then we have 5 endpoints, right. We have 5 endpoints of that things. So, what will happen that basically it will remove all the endpoints from the load balancer, so that will be now called. Okay. This is very important to know, because we need to handle this very carefully in our code. Each virtual machine hosting a web or worker will receive a stopping in event. Once host operating system update starts, at the time we will get a the stopping event. Okay, we have the stopping event, and we need to in our code we need to handle in such a way that suppose we are in middle of something. If you don't handle that things, then what will happen? Our application will stop at that moment, right? So, once we need to, that is the reason when you are writing any code actually in the Azure, we should have a on stopping event. What will happen that whenever OS operating system upgrade starts, that will fire a stopping event. So, we will get that actually in the code level, right? So, at that moment what we need to do that, we need to write our code that so that we will gracefully stop our all applications. We need to write, get my point. Whatever things you need to, either we can complete everything if needed and roll back. So, that means we need to make sure that actually that our application stops gracefully. There is nothing actually in middle breaks or something. Right? And but we need to take care one thing. Third point, that is the reason. Third point is very important. Worker, web and virtual roles are allowed 5 minutes to respond to the stopping. Otherwise, what will happen that automatic forcing, it will force to stop you after 5 minutes. So, that is what about the codes. Suppose I am writing something I am in the middle of database transactions, and it will take another 10 minutes. It will not happen. That is actually probably we can just some things immediately we need to log something that, or we need to just roll back something immediately. You need to make sure that whatever the operations you will and do in the on stopping event, it should complete within the 5 minutes. Otherwise, whatever the automatic fabric control will forcible stops. Okay, that forcibly stop the instances of the web role worker role. So once all the guest virtual machines are stopped, that means guest operating systems are stopped. That means our instances of the web roles and work roles are stopped. All the instances of host operating system, all the instances of the web roles and work roles are stopped. Then root partition web operating system shutdowns. That means our guest operating system. Getting your point? We have the host operating system. Then we have the partitions root, right? Root partition is the guest operating system. Sorry, host operating system, and child partitions is the guest operating system. So once all the web roles, all the instances of web roles and work roles are stopped, then root partitions shutdowns. Exactly. These are the virtual machines, na? These are the virtual machines. Are you getting it? These are the child partition. These are the virtual machines. Once those are stopped, then host operating systems shutdown starts, and then it will reboot.
One thing here, like how this fault domain you said and upgrade domain, they're different actually. I'm not getting it.
I will tell.
Yeah, I also have.
I will cover. Basically, let's first concept. Basically, complete the concept, sir. I have those points also in other slides. Okay. So that means after that updated root of partitions operating system starts, right? Once it shutdowns, reboots, then the starts. Then what will happen? Same procedure. Once our host operating system starts, right? That partitions of then the virtual machine hosted on the server root and start their application code. That means all the instances of web roles and worker roles again start. Okay. So that is the reason when we have any host operating system updates, it will take some time. It will take 15 to 20 minutes, because at that moment we need to follow all the points, right? First, it will remove all the endpoints of the web roles and worker roles from the load balancers. Second, it will fire a stuffing event, and it will wait for 5 minutes, obviously. So suppose we have thousands of instances, then obviously you need to wait for 5 minutes, right? Then nothing. Forcibly after 5 minutes, automatically force the thing. It will automatically basically forcibly stop that virtual machines. Okay. So once all the virtual machines are stopped, right, then our host operating system shutdowns and rebooted. Okay. Then once that host operating system, so that means that our root partition operating system off, then all the virtual machines will be off also. So it will obviously take the time, right? But case is very different for the guest operating system. You know, actually guest operating system is just for that service, right? So it is very similar to like our Windows restart, nothing else. Okay, and so many people start actually when we have the, you know, actually when we install patch in our Windows application or Windows server or something, it will take so many times, right? It takes generally so many time, 1 hour, 2 hours, 3 hours, right? But this is not the case, because internally it will get all the patch functionalities, it will create an image, okay, and save that VHD file, that image VHD files in the storage account of the all the virtual machines. So what will happen, that when it will reboot, it will just reuse that image, nothing else. So that reason it is taking very less time. Otherwise it should take actually 1 hour, 2 or 3 hours. Are you getting the point? Once basically that it will get the patch, it will be distributed to all virtual machines. It will create a VHD files and distribute it to all. Okay. So guest operating system is the basically like our rebooting of the virtual machine, nothing else. Okay. And that is the reason guest operating system upgrade is much faster than the waste of basically the host operating system upgrade. Okay. And another thing that we have here, see what is the difference as a hosting point of view, deployment of view, what we should take care. We don't have any control whether to avoid the host operating system update, but we can control the guest operating system update, right? Fabric control, whenever there is need, automatically Azure will update the host operating system once a month or once a quarter. There is no way we can basically avoid that manually. We can do that manually. Automatically Azure will handle this for us, and we will just get a stopping event. Every virtual machines will get a stopping event, and you need to handle our code gracefully, carefully, so that it will not shut down the virtual machines gracefully. Okay, getting my point. But there is a way we can handle our guest operating system update manually. In the Azure portal or in the service definitions, what we can do, we can tell that actually I need this cost operating system update, so that automatically what will happen, that every time we have the host operating system, guest operating system update, it will not update automatically. You need Azure will not update the guest operating system automatically for you. You need to do this manually. There is options. Okay, I'll tell that actually how we can handle that. That means actually basically in one line we can make it manual. Okay, exactly. Exactly. So we can control that part. So we can tell the Azure that no, you don't need to update the host operating system manually, guest operating system manually. I will handle that. Okay. So now we have three things very important. First, the fault domains, update domains, host operating system update, guest operating system update. So we understand that even without any network failure, without any hardware failure, without any service crash, once a month or once a quarter, we'll have this. All the virtual machine will be restarted, and we know that PaaS. That means that time our application will be unavailable, right? Obviously, right? Our virtual machine will be restarted means at the time. So we know also that host operating system updates will take minimum 15 to 20 minutes, and guest operating system will take 1 to 2 minutes or something. It is the same time as our Windows service, Windows reboot, simple Windows server reboot. It will not take that much time. Obviously, that time also our application will be available, right? Will be unavailable, right, at that moment. So let's discuss how we can handle that. Already we have discussed one point, that first thing is that we can make our guest operating system updates manual. We'll tell that Azure, we should not bother about our guest operating system update. We'll take care of that part. We are taking that responsibility from the Azure, getting, but we cannot control that in the host operating system. Automatically, Azure will automatically do that for us. We cannot control that part. Okay, that is the reason in SLA, means service level agreement in Azure, they have told clearly that, it is mentioned clearly that Azure, we guarantee that your applications will be, Azure applications will be available up to 99.9% if you have at least 2 instances. Otherwise, there is no guarantee that your application will be available. At any moment, your applications can be unavailable, means any moment, right? So that is, Azure is guaranteeing that at least we should have a 2 instances, so that we can guarantee that your application will be available up to 99.9%. Otherwise, there is no guarantee. So first thing we need to think that when we develop our applications, we need to think that we need to develop our applications with minimum 2 instances. So web role means web applications. Worker role is most of the things we are doing the background jobs, right? Background tasks. We can talk about our scheduler type of things, and we can think of like our Windows services. So that is the reason when we develop our applications, we should take those points into considerations. How we can make our application multi-instances. Suppose you are storing the sessions in the info, then if you make the multi-instances, then obviously it will not work. That are the things you need to take care, right? In the initial level, actually, when you start the developing applications, you need to take care of that. Where you need to store our session, obviously it will be out of process. Obviously it should be either cache and or in database. Getting point? And when we are talking about the background, suppose we are getting any some data in the file structure in Excel sheet or something, or CSV file, and we are processing that data and storing the database. Suppose we are doing that and we have created one worker role. So there is a chance of duplicacy, right? If you make it multi-instance, so what will happen that? It will run the same code multiple times. So we need to take care of those points actually when we should start developing the Azure applications. To keeping that, our applications need minimum 2 instances to make it 99.9% available. Okay, this is the first one. So obviously, when we are talking about the our object domains and fault domains, and we know that our applications will be rebooted once a month or the quarter month. That is very important. We need to take care first. Let's discuss first all the things. So that means we need to handle that also. Apart from that is the reason it is mentioned in the SLA, and most important thing that we need minimum 2 instances in web role or the worker role. So what will happen that when we create 2 instances for worker role, web role, then what will happen that internally Fabric controller will put each basically each web role or each instance of web role worker role in different object domain and the fault domains. He will take care of everything for you. There is no need to bother. Getting my point? So automatically what will happen that if we have 2 instances, when we will have the host operating system update, what will happen? We know, we have discussed, right? Whenever we will have the host operating system update, it will first update only all the virtual machines in one update domain only. Then it will go to the next update domain. That is the technique they are using. Getting my point? So that obviously our application will be available always. That means what? Whenever we will have the host operating system update also, one web role will be down, and another one instance of web role will be down, another instance will be available. Think another scenario. Suppose we have designed our applications to multi instances to handle the load, because once you know that is called actually in other technology in the IS level, actually it is called web garden. That means why we need the web garden? Because one instance of the IS, that one state of application is not able to handle your load. So that is in what we are doing. We are creating the multi instance of web applications, and load balancer will be present in the middle. It will basically get the request, and based your load of their applications, it will basically channelize your end user request to different endpoints. Getting point? That is the reason we need the web garden, or sometimes we need the web farm also. Getting my point? This concept is called web farms. Web garden is for the worker process. Why inside the IS level we can have the multiple worker process, so that a request can be handled multiple worker process inside. But this concept is called web farms. That means we have in different servers we have the same code is deployed. Okay, and in middle we have the load balancers, and load balancer will direct the request to different servers based on the loads. So this is the case here also. Think one point. Think the scenario one. Suppose host operating system update starts. Okay, at the time one instance is down, and at the time probably other instances will not able to handle all requests, because it is our application is not, our scalability point of view, it is not able to hold the request. So what will happen? That will be down also. So many requests it will be, right? Because all the requests before, what's happened before, actually requests were channelized to 2 instances. Now all the requests will go to one instance of the web role. So obviously down. So that is the reason some Azure also telling, and I discussed with Azure guy also, they are telling that we need minimum based on your loads, based on the scalability point of view, how many users you will use your application at a point. To make our application, that is when I have told one point, scalability is very important. It is very closely related to the availability. Getting my point? So that is the reason we need minimum 3 instances. That means if your application is able to handle the handle in 2 instances, that means we need 3 instances, might be in some cases 4 instances also. So that is they are telling that we need minimum 4 instances to make our applications highly available. 4 instances. Do you know why that 4 instances? By somehow update domains, due to OS operating system updates, one update
Yeah, that also can go down. The domain.
suppose one instance is down because it is due to host operating system updates. At the same time, suppose hardware fails, then what will happen? Other that will be also down. If you call the 4, then what will happen? It will handle all the things that the reason fault domain concept starts. What will happen that whenever we will have any hardware failures or service failures, what will happen? That only one instances will fail. One instances of the one fault domain will be down at a time. Are you getting the point? Concept is that suppose we have the 2 instances and we have any hardware failure, then what will happen? That only one instance of one update domain, one fault domain will be down at the time, other will be available. So think of that, one down for the OS operating system update, that is present in the update domain concept, and another down for the hardware failure. That means that is comes under the fault domain concept. That then both will be down. So that way we need minimum 4, so that fabric control can manage our instances. Getting your point? Are you getting the things right? The algorithm behind this. So minimum we need 4 instances to make our applications available.
So, suppose if we have a very large number of users accessing our application and the 2 of the instances cannot
That is the generation. That is then obviously we go for 5, 6, 10. Obviously, we are discussing about the minimum stuffs. Minimum 4. If you think that your application should be handled by only 2 instances based on the lot scalability point of view, then obviously we need the 4. But you don't think that actually 2 instances is not sufficient to handle your loads also, then obviously you need to increase. 5, 6, 10, obviously you need to go.
Based on scalability plus 2.
Exactly. Are you getting me? I am discussing all the time minimum with the update domains, fault domains, what will happen. Minimum things. If your applications can be handled with 2 instances only, from the scalability point of view. Getting it? Without that, we should not think of actually any guarantee of that your application will be available. Got my point? And make guest operating system update manual. We discussed how we can do. Basically, I will show actually after that this seminar itself. I will show. Okay. I have discussed all. I have already discussed the scalability here. And I can just point out, when we are discussing about the scalability points, it can be different. CPU utilizations, your bandwidth, your network usage, right? We need to consider all the things. In Azure, we have a portal basically, right? From the portal itself, we can get to know actually basically all the usage of all instances, CPU usage, bandwidth, and the network usage, everything. Based on these things, we can scale your applications. So, sorry. So should you always do this manually? No, right? We cannot know actually when your CPU utilization will be high, when it will down also, right? We do not know. That is the reason there is a nice concept present in the Azure, that is auto scaling. We can give different rules. When my CPU utilization is greater than 60% for 10 minutes, make my role instance to increase another one. Suppose now I have my application is running in 2 instances, then make it to 3. And if my CPU utilization is less than 10 for the 10 minutes, make it to right, remove 2 instances, it will be 1. That way we can save so many money, basically. Getting my point? That is very important. When you are deploying an application to Azure, cost is involved, right? It is not free. So that is very important also. You need to take considerations. What is the size of the virtual machines? What is the role size of the role instance? That is also you need to take care this part. So auto scaling, it is scaling in horizontal way, not the vertical. Right? We can just increase the size. We can increase the instances. We cannot increase the size. If you want to increase the size of the virtual machine, then we need to go for another deployment. In the Azure portal itself, we cannot manage that, and there is no way that actually we can also dynamically handle that. Auto scaling is just
RAM or something.
yeah,
By increasing
RAM and
virtual machine means increasing RAM.
increasing the instances. Suppose we are talking about the I am talking about the increase the instances of the suppose I am waging the suppose some small virtual machines. That means based on the RAM size, hard disk size, all the things it is categorized, right? All the things, or how much bandwidth it can support.
Yeah, then they totally have different categories.
Exactly. So auto scaling means we can just increase the instances, but we cannot increase the size of the virtual machine itself. That way we cannot do. Suppose that also we can handle, the right? Suppose now my virtual machine is small. Probably if you increase to extra small, extra large, then probably it can handle. But that way we cannot handle.
Auto scaling will not.
Or no, auto scaling means increasing the instances of the size, instances of the web role, not this. There is a role in Azure portal itself. There is role actually involved. Suppose you can tell actually if CPU utilization is greater than 90% for the 10 minutes, then just increase. We can write that role on automatic role. And also there is API involved. In code level also you can check actually the CPU utilization, bandwidth utilizations, your basically the what is RAM utilizations, memory utilizations, and network usage utilization also. Based on that we can do that also.
We can do separately for web roles and worker roles, or
Obviously, when you deploy applications, web roles and work roles are different, right? Inside that cloud service, web roles and work roles are different, right? I will give some examples of that. Okay. Let's discuss the based on that actually protection against hardware failures. How we can do? We can answer right now. Obviously, right?
Means fault will be down. Fault.
That means concept is fault domains, and we don't need to. We are going for PaaS means we should not bother about anything. Based on SLA, just you need to make sure that at least we should have 2 instances of a web roles or virtual roles, sorry, worker roles. Okay. Fabric control will handle everything for you. Getting protection against software failures. We discussed, right? Fabric control every 15 minutes or sometimes actually it will check for the health of the every worker roles and web roles. It will find any actually failure in the software or the code. It will again basically restart that code. Although even needed, it will restart a virtual machine also. And if needed also, it will create a new virtual machines for that new role. Okay. So automatically it will handle everything. The ability to update application with no application downtime. So when we are deploying, the best example is that when we are deploying our applications, now we have the downtime because we have now 1 instances, right? If we will have the 2 instances, what will happen? Think. There will be no downtime because it will first update the code in 1 instances into 1 update domain, particular domain. Okay. Then again it will, once it is off, then it will update the code for the another instance of the another update domain.
This is also done
Automatically. To make sure that we will have the 2 instances of a web role or worker role. Getting point?
The same rule applies.
Yes, because automatically when we will have the 2 instances of a web role or worker role, Fabric control will automatically place each instances to different update domains or the fault domains. Are you getting point? Suppose instances will be placed in the update domain 1, instance 2 will be present in the update domain 2. So when you update our code, what will happen that instances 1 present in the update domain 1 will be first updated. Then once it is off, then what will happen then? Instances 2 present in the update domain 2 will be updated.
Here it is written like once these instances are running, it can do the same. It is automatic. We are
Which
not
one?
going to redeploy in another instance.
No. In one deployment itself it will handle everything.
So we have to mention that in the configuration, like how many instances you are.
Obviously, na? That is the obvious thing. 2 instances obviously, na? Minimum 2 instances. If for 5 different things, minimum we need the 2 instances to make this happen. Okay. Ability to update Windows and other supporting software with no application domain. Answer is obviously again update domain, right? whenever any update or Windows software update or something will happen, obviously Fabric control will handle that way also itself. First it will update the one instance present in one update domain, then it will update the other instance present in the other update domain. Getting? So that means Fabric control automatically thinks that the whoever is using the Azure applications, it follows these rules. It should have at least minimum 2 instances. Otherwise, there is no guarantee actually. That is the reason what will happen. Suppose we have the one instances, what will happen? That way also, that time also Fabric control will automatically start there. He will not think actually whether we have 2 instances, 3 instances. Whenever we have the one instances, obviously it will put that instance in one update domain. He does not understand actually whether there is other update domain or other instance present of the update domain or not. That time also it will just restart the machine and it will start updating. That time our applications will be down. That means, right? Are you getting me?
They can be means one more step. The Fabric control can be smart enough when they are updating. Let's say I am a small user, only 10 users are active. So I will not go for scalability. I have only one instance. So every time this update is happening, it can create a new instance also in an already updated host domain.
No.
And that kind of thing.
No. Fabric
Only their business continues.
Exactly. They should think of that one, and that is the reason to make this happen. What we can do probably when we are doing the deployment point of view. That is the reason actually when we have the one instances, we need to take at some points. We have done also in our applications. First thing is that we need to make our guest operating system manual, so that there will be no reboot also, and we need to handle our on stopping event very carefully. Okay, and when we deploy our applications, make first deploy the staging environment, then do a VIP switch swapping, so that it getting my point. That if you do that, then what will happen that at the time, if you directly update your production environment, then what will happen? Your application is down for the 10 to 15 minutes. But if you go for staging environment with same code base, everything is fine. Okay, the VIP switch takes you 2-3 minutes, max to 1 to 2 minutes or 3 minutes, right? So we have the less. That means
That time it will make staging and production.
staging in the production. It is just a VIP switch.
Yeah, you have option to switch the staging and production.
It will switch the staging to production. Production will become the staging. Okay, that
Anyway, we need to.
anyway to environment, but at that time, after that we just delete that one, because you don't want to spend much time, right? You don't want to spend much money on that. So you want to adjust all the things in one instances, and you don't need actually practical purpose. You tell them actually yes, I can tolerate the host operating system update actually once a month or quarter a month, then it is fine. If you are fine on that point, it is good, not a problem. But yes, but this part is very important. When you are doing for the deployment or suppose you are changing some configurations, that time also it will happen. That time what we need to do, same way we need to go. Create a staging, make it to multiple. Basically, what we need to do. Suppose I have one instance. Okay, I need to change some configurations in the Azure. So when I will change then save this, what will happen? At the time also my basically the virtual machine will restart, right? It will reboot. So to avoid this, what you need to before that make it to 2 instances. In portal itself, make it to 2 instances. Change the configurations, save, again make it to 1. These are the some things you need to. These are the some points you need to take care. Otherwise, your application will unavailable. Are you getting my point? So, but Azure's perspective point of view, but based on their SLAs, service level agreement, they are telling that there is no guarantee if you have only one instances. That getting my point? Okay, so these are some resources from where actually I have collected all the things. You can go through these links. Any questions? Then we can discuss.
Same question actually. Still, like
Actually,
what do we
let's
get
suppose
with this
yeah,
update?
we have an application and we want to deploy it. So let's suppose we are having 2 instances and 3 gate domains.
See, that algorithm we cannot handle. Fabric control.
Different actually. Fault domain is a hardware thing.
Hmm.
Update domain is logical unit.
Yeah.
Means
So what will happen that, see, suppose I can is it, no.
like one fault domain can have two update domains also, right?
Yeah.
Is it like that? One fault domain, like one.
Suppose I can show you something. Is the chunk available or marker is available here? See, basically we can think like it is in practical those are not present, right? We can tell that these are the this is the object domains or the in practical it is not present. In physically it is not present. But they are setting that actually. So when we are updating the things, we should just update this probably this virtual machine. Then after that, once you complete this, we will update these sets of virtual machines. Suppose you have 10 virtual machines, you can think like that. Okay, they have put actually 5 virtual machines one update domain, another 5 virtual machine, another update domain. And when fabric control assigns, suppose we have made 3 instances. So fabric control will have all automatically create the instances for the web roles, and it suppose creates 2 instances in update domain 1 and another instance in update domain 2. Okay. When we are talking about the fault domain, might be suppose we have 3 instances, it will might be same virtual shields come under also same another fault domain might be. So one instances can be comes under the same update domain and not same update domain 1 and fault domain 1 also. Getting your point? So both are different, but thing is that whenever we'll have the update, then update domains based on the update domains they are updating the virtual machines. When you have any faults, they are updating the virtual machine based on the fault domains. Are you getting my point? We can think like this. They are separating the virtual machine based on the 2 concepts. One concept is for the updates, another concept the faults. Faults is different and updates is different. Updates is different and faults is different. Faults means some failure related. We have suppose hardware down. Suppose you have network is down. Suppose server crashes. It is different concept. Update means when we have a update of the applications, update of the operating system, update of the service, anything related to this is called update, right? So what happened? Physical tell that actually suppose we have 10 virtual machines. I can separate the virtual machine for the 3 sets of virtual machines. I can separate it to 3 groups, and I can assign actually different virtual machines to that one. So in my algorithm, I will tell that actually whenever there will be update actually, I will just first update the all the virtual machines present in the update domain 1. Then I will go to the second update domain, then I will go to the third domain. I should not update all the virtual machines present in the 2 update domains. Then what will happen that it will create problem. Are you getting point? Algorithm should be written in such a way that I should update the only what update domains. Virtual machines present in 1 update domain, and fault domain is we can think practical for suppose. So they should arrange actually it is a physical structure, because otherwise it is not possible. Update domain for the update domain there is no need of physical arrangement, which were right, because we are just updating the things. We tell that actually I can assign this virtual machine that one, but in algorithm, inside the algorithm for updates operating system, I will tell that actually I will check actually suppose how many update domains are present. 10 update domains are present. Then I will check actually in the loop, get all the virtual machine present in update domain 1, first update. Reboot started, off, I will check that health condition is right, then go to the second update domain. Get all the virtual machines, then update, I will go to the third one. But fault domains should be related to the physical structure, because whenever there is a hardware failure, suppose we have been connected, suppose our server is down now, then we will not connect to the LAN, right? Because our network is down now. That means this infrastructure should be present in 1 fault domain, because somehow if something happens, then hardware failure, then it will. That is when they are called as a rack. In data centers they have different racks, right? So what their hardware network is related to that rack. So anything happens to that rack, right? That should not be communicated to other racks. So they have based on that actually they have created different separations. That means they are telling that they know that actually these virtual machines are present, or these physical machines are present in one rack, okay, and other physical machines are present in another rack. So something will happen, then obviously it will happen to only that rack. There is no chance that it will happen to other rack also. So that means if we have the hardware failure, obviously that will happen to that one. That is then what will happen then when we tell that actually fabric controller I need the two instances, what will done? Suppose we can tell actually this infrastructure room 1 and room 2. We can tell actually we have the data center here, we have the 10 rooms, okay. All the machines present in the room 1 is right present in the room 1, room 2, room 3. So when you tell that virtual machines, fabric controller that I need two instances overall, he will assign one virtual machine, physical machine of one virtual machine in room 1, another physical machine, another virtual machines in room 2. So if something will fail, if something will happen in the room 2, that will not affect to the virtual machine or physical machines in the room 2, room 1. Are you getting the concept? That way it will handles. Okay. Any questions? Any other questions? I think. Guys, Sudhanshu, you have any questions? Okay. Hello. Guys who are attending the seminar remotely, any questions? Okay, basically then in next seminar I will cover basically how we can handle the first question is basically if a total data center is lost due to some natural disaster or something, what will happen, okay, and how we can handle the applications in the code level itself, so that our applications will be, suppose when we are deploying the application to the Azure and in cloud, any in cloud infrastructure, the chance of that network latency, right, tangent error, or sometimes our probably your storage is not able to handle your request, right. So how that 2 points we discussed, separation of concerns basically, right, and also the service and architecture, and there is concept in service also in the was in Azure also. So we'll discuss more on that part, and that is very important when you architect our applications. We'll go in the application level, the code level, how our application should be architected to make our application 100% available. This discussion, all the things we discussed related to all basically to make sure that applications are available for any hardware failure, software update, hardware update, all the things, right. It is nothing related to our code level. So how we should architect our applications in when we are going to deploy in Azure, so that our applications will be 100% available. How getting a point? So we'll discuss in our next seminar. Okay. Thank you guys for attending the seminar.